Good evening, everyone, and welcome to our Cooperative Extension Learn at Home webinar series. Tonight's topic is Sweet Discoveries from Maple, Medicine, Beauty, and more. I am so excited to learn more about this topic, and I hope you are too. My name is Vanessa Ventrini. I am a University of Rhode Island Cooperative Extension educator, and we are so proud to bring this to you from the College of the Environment and Life Sciences. And tonight we'll actually be hearing from our colleague from the Department of Biomedical and Pharmaceutical Sciences. So you can go right ahead and click forward. So here at Cooperative Extension, we are the land grant arm of the university, meaning that we bring the science of the university system to the people of Rhode Island, and as we see on this call, people all across the United States. And we are committed to doing this to improve quality of life, health of our environment, and of course, improving the lives of everyone on this call. And we have a number of different areas of focus, everything from land stewardship, helping people contribute to their food systems and agriculture, improving water quality, energy efficiency, and healthy lifestyles. Just a few little items of housekeeping. We're going to go ahead in a moment and start our webinar, but if you have any questions, enter those into the question and answer section you'll see on the bottom right, and we'll do our best to answer those at the end of the program. We do ask that you please answer our brief survey that will be sent to you in an email after the class, and that helps us improve our offerings in the future and see how we did so far. And of course, this talk is being recorded, and you will be able to find it within a week on the URI Cooperative Extension YouTube channel. So we invite you to check that YouTube channel out, because you'll see all of our past talks with closed captioning added to them after. So we want these talks to be accessible to all, and that's why we're so excited to be able to offer these webinars to people all over the place. Okay. So I am so pleased to introduce tonight's speaker, Dr. Navindra Saram. He is both a professor and the chair of the Department of Biomedical and Pharmaceutical Sciences at the University of Rhode Island. Navindra is one of the most highly cited scientists in his field and has published over 200 peer-reviewed papers. And he is regularly quoted in the media and popular press about medicinal plant foods. And tonight we're going to hear all about his maple research. Maple is one of my favorite things. So without further ado, Dr. Navindra Saram.
Thank you, Vanessa, for having me on this webinar, and for all of those who are joining, good evening, good afternoon for you, those of you who are on the West Coast. I thought it would be good to just start off by giving you an outline slide. For those of you who are on my time zone, it's 7 p.m. And as a good professor always does for evening classes, we tell students what we're going to talk about. So by the time I get to maple research, they'll know maybe I'm midway and I can get to Q&A. So talking about Q&A, I'll make sure that I leave maybe 10 minutes, 10 till 8 to field your questions. Hopefully we can have a lively discussion. But I'd like to start off briefly, before I get into the maple research that we have done here at the University of Rhode Island, give you a brief introduction into natural products and plant-derived drugs, a little bit about medicinal plant foods and human health, and then hopefully that would set the stage for our discussion on maple research. You're probably wondering why a pharmacy professor is telling you about maple. And the reason is there is a discipline or a field called pharmacognosy. And I like to tell my students that pharmacognosy is the quote unquote mother, if you will, of pharmacy. It's that field of discovery of drugs from nature, the discovery of medicinal compounds from natural sources. And the field is natural product research, but it involves the discovery of drugs from nature. And nature in this case means plants. Sometimes it could be sponges, bacteria, fungi. So whatever is naturally occurring and is used and has been used for sources of medicines, which scientists like myself would really get into that natural source and then try to identify what in that natural source or that tissue, if you will, or that food or that plant leaf or fruit or bark or root is actually responsible for the biological effect of that natural source. And we can identify it, and potentially we could develop drugs, hence the link to pharmacy. Oops, let me see here. It doesn't want to advance. Let me see. Oops, here we go. Why is this important? The University of Rhode Island, why is this important to URI? Well, we have had, the University of Rhode Island has had a very rich and long history in natural product research. In fact, I'm showing you here a slide that I'm going to use the quote unquote pharmacognosy Bible, a textbook of pharmacognosy. And this book was written by a famous pharmacognosist. His name is Heber Youngkin. Heber Youngkin Sr., that is, was the father of our first dean at the College of Pharmacy here in the Kingston campus at URI, Heber Youngkin Jr. So you could kind of imagine when Heber W. Youngkin Jr. started off the College of Pharmacy here in the Kingston campus, how strong a connection he had with pharmacognosy based from his father and also for himself. And right now, I'm actually in my office, if you could see the background, but right outside of my window, I'm looking at the University of Rhode Island endowed Heber W. Youngkin Jr., named after our first dean, medicinal garden. It's beautiful. We have over 100 plants right now. Well, now is not a good time of the year, obviously because of the weather, but still, if you look at this arrow, these beds here, starting from the College of Pharmacy going all the way over, we have medicinal plants from all parts of the world. And interestingly enough, we have this glass frieze you can see here that's lit up right now at night. It's beautiful. We have the medicinal plant beds, this Materia Medica frieze, and a birch grove. It's really wonderful during the summer and springtime, and even now in the fall, when students and the community can come into the garden and really look at plants and really, kind of focus on health and wellness and the relationship between plants with their healing properties and humans. So it's a privilege for me as a department chair and also as a faculty to have this teaching tool, if you will, that I would use when I'm teaching my medicinal plants class to students here at URI. So they're showing a better, this is the pharmacy college. I'm actually in this room here right now. That's just my office and overlooking the garden. This is a memorial stone named after our dean, as I said, Heber W. Youngkin Jr. And here are the plants. Each of the plant has a nice small label on it, that's so you could actually learn about it. And please, if you are from Rhode Island, even if you're not, and you happen to come to the Kingston campus, during the summer or the spring, we really encourage you. We want to show you what we have here in our garden. So hopefully you can come and appreciate our medicinal plants. Why are plant medicines important? Well, some of you may know this, but the Eastern cultures, I'm going to say Eastern cultures, many Eastern cultures, but not only Eastern cultures, but traditional cultures, they have used and still do use plants as their first line of defenses against different diseases. In fact, traditional Chinese medicine is a good example. It's called TCM, or the traditional Indian system of medicine called Ayurveda, which, by the way, yoga is a part of Ayurveda, or the indigenous peoples of North America or of Africa or from Latin America, wherever they are, from the Amazon, they've figured out ways to take plants and actually use them as extracts, as tinctures, as teas, as powders, to ward off or maybe help them with different types of diseases and illnesses. Sometimes using these plants maybe for hunting. They'll take toxins from plants and then hunt their prey, or take it for maybe, I don't know, a tummy ache or a toothache. And currently, the World Health Organization estimates that about 80% of people right now. People who don't have what we have here in the developed world, going into a pharmacy that we're used to doing it, and picking up, something over the counter, or meeting with our physician and going to our pharmacist to get a prescription filled. Many people are still using plants as their first line of defense against diseases, and that's impactful when you really think of what is happening on a global level internationally. And right now with the COVID pandemic, even more so, I think people turn towards plants to boost their immune system and for antiviral prevention and cures and treatments, etc. All right, having a little, here we go. So if you look at a plant, and I tell my students this all the time, by definition, plants are planted, they're rooted, and therefore the plant cannot get up and run away or escape from harmful UV radiation. They can't put on sunblock like we would do if we go to the beach. They can't use an antibacterial agent. So the plant has to really engineer mechanisms to protect itself from, again, harmful UV radiation or insults from bacteria or fungi. And you can look at your top left, if you were to go to Yosemite, look at that. I don't know, it's a creature, a plant. It's a tree that lives for thousands of years. And if you think of its bark like being its skin, you could kind of imagine that plant maybe making compounds or biosynthesizing compounds, which it would keep in its tissues to protect itself. And indeed, that is the case where the plant now goes into some very complicated chemical biosynthetic pathways to manufacture drug-like compounds, if you will, and it has those in its tissues. So it would say, herbivore, don't eat me. My leaves are not going to be good for you. You're going to get ill. Or it may be, my berries are colorful. Come and eat me and disperse of my seed. So whatever the case is, the plant is actually manufacturing or actually making these compounds to give itself a competitive advantage. And you can imagine that as humans evolved with plants, they're trying to now figure out what in that plant is actually good for them. So this slide just shows an example of some drugs, in fact, a drug that was obtained from a plant. And this is just one of several examples. This plant shown here is the willow bark. And in medieval England, when they would have pain, the local people figured out how to take the bark of the willow and chew on it. And by chewing on it, they find that the pain and the inflammation would go away. And it was years after that salicin, a constituent that was isolated from the bark of the willow tree, was then synthesized into a drug which we know has been around for 100 years, a little pill called aspirin, and it's still there. So you can imagine compounds from plants which are taken from the plant and developed into drugs, maybe modified to become a better drug. But certainly there are several examples. I can throw out others like caffeine. I'm a heavy coffee drinker. Many of you are also. Caffeine is, by the way, also present in tea. That's a drug-like compound, as well as other compounds like nicotine from the tobacco leaf, or digoxin, which is a cardiac glycoside from the foxglove. This is another example shown here, a popular anti-cancer drug that's used for ovarian or breast cancer. It's called Taxol or paclitaxel, which is isolated from the bark of the Pacific yew. So the point I'm trying to make here is that plants have provided humans with drug-like molecules, as shown here in the bottom right, for pharmaceuticals that you can actually, take for different diseases. In addition, if I were to shift gears away from pharmaceuticals, which are drugs, but really maybe reflect a little bit on plants that we eat, edible plants. And by the way, I must say that many plants are toxic, as you know, but the ones which we eat, which are composed of, a lot of colorful fruit and vegetables and grains and so on, and their derived products like green tea or red wine or olive oil. the list is extensive, but clearly data has shown that if humans eat a plant-based diet or a diet which is rich in plant-based foods, that they can certainly reduce the risk of getting certain types of cancers and heart disease and neurodegenerative diseases and so on. That one you can take to the bank. So for all you vegetarians out there who are listening in, even if you're not a vegetarian, I encourage you to try to get your 5 to 7 servings of fruit and vegetables and their derived products. If you really want to give yourself some added protection that plant-rich diets could give you. So here we go, similar DNA, different diets, and if you have to look at what ancient man used to eat 50,000 years ago, if you will, with fruits and a variety of fruits and nuts and seeds and roots and tubers and flowers and leaves and stalks and beans and no processed foods and no dairy, no alcohol, no tobacco. Whereas, you could look at what we're having right now, a lot of added fat and sugar and high fat proteins and processed foods and refined foods, where really our diets have changed what it was and what it is today. No wonder we have maybe the incidences of certain types of diseases. All right. So our divergence from plant-based diets have led to a lot of diseases. And this slide is just showing an adaptation from a book written by David Heber. I used to work in his group before I came to URI. He was a professor at UCLA School of Medicine. He wrote this book called What Color is Your Diet? He's not the first one to come up with this concept, but the idea that humans can see color for a reason. And if you're looking in your plate and you're seeing colorful red foods, like you have tomatoes, the red purple type of foods like berries and grapes and possibly some red wine, and the orange color for foods like pumpkins and carrots, and the orange yellow types of foods like citrus and pineapples, and the yellow green type of foods like avocados and certain beans, or the green type of foods like broccoli and the cruciferous vegetables, and even the white green type of foods like your garlic and your onions and your chives. That if you're eating for color and you're eating colorful foods, that you can potentially really protect and prevent a variety of chronic human illnesses. So it's an interesting thought when you really realize how humans we can see color and we co-evolve with plants. And I like to think that maybe plants and humans, as we co-evolve together, that humans were selecting the best plants, or maybe plants were selecting the best humans for us to cultivate them and harness them, if you will, for their potential health beneficial compounds, because we've been eating these for such a long time, for centuries. All right, this slide is just a chemistry slide, but I'll come back to this when we start talking about maple, which we'll do like in a second. But just to show you that if you're really eating a lot of fruit and vegetables, like your broccoli and your carrots, and drinking your orange juice or your green or black tea, and eating your berries, and maybe having a moderate glass of red wine, eating your whole wheat and maybe your soy, as well as some coffee here, and having berries that you can actually consume. This slide is just showing you a large class of dietary phytochemicals, if you will. Phytochemicals being these plant compounds, plant chemicals, which are called polyphenols or phenolics. And this class of chemical compounds, is very abundant and very ubiquitous in dietary plant foods. And it's estimated that if you're eating a lot of plant foods, you can actually consume over 1 gram of these compounds per day. So you can imagine, now these are molecules which are, as I said, drug-like, but they're not drugs, they're not toxic. They're dietary because their levels are lower, but they're not fats or carbohydrates or proteins or vitamins or minerals. These are actual hardcore chemical compounds called secondary metabolites, which, as I referred to earlier, are natural products that the plant has produced for its own purpose. For example, resveratrol, here shown here with the arrow, is a well-known molecule which is known to be present in the purple grape and hence in red wine. And this compound is actually a phytoalexin. It's produced by grape to fight off fungi and fungal attacks. So if the grape plant or the grape berry fruit is under fungal attack, it produces this molecule in its tissues. We eat it, or of course you don't want to eat something that has fungus in it. We extract it to make red wine, and then this compound is then present in red wine, and similar for the other natural products that are shown here. Okay, with that brief intro, I think I took a little extra time there, but I'll speed it up. I'd like to get into our maple research. So the story starts in 2009. I'm showing you the U.S. map here because, as I just mentioned, I was moving jobs and I was leaving Los Angeles, California, to move to the East Coast in 2008 when I started my job here at the University of Rhode Island College of Pharmacy, and I'm moving cross country, and I'm thinking, well, you know, when I was here, I was working and doing a lot of research on of course, everything grows in California, as you know. I was working on berries, on some tree nuts, on pomegranates, and a variety of other natural products. But you know, what was going to be my new project, my new pomegranate, if you will, when I moved to Rhode Island? So that was an interesting question that I had to answer. And it became evident to me very soon after. Now, I am actually, should have mentioned this, I'm actually from the Caribbean. I'm from South America. I'm a third generation East Indian. I grew up in the British colony of Guyana, now known as Guyana. If you remember your geography, there are three Guyanas, British, Dutch, and French. Dutch Guyana is renamed Suriname. French Guyana is French Guyana. British Guyana is Guyana. It's actually very close to Brazil and Venezuela. The only English-speaking colony in in South America. But when I grew up in Guyana, which I should have mentioned, you know, we were a third world country, and our sources of medicines was what mom and grandma told us to use from the Amazon forest. Maple syrup doesn't exist for us, so I didn't know what maple syrup was. And even when I migrated to the United States, and it turns out that a lot of people, if you're not from the New England area or the northeastern part of North America, you may not necessarily know what pure maple syrup is. The industry has actually looked at how many people think, and still do, that pancake syrup is pure maple syrup, which it's not. As many of you may know, pancake syrup is usually a high fructose corn syrup based syrup that's flavored with maple. Popular brands are sold, but certainly maple syrup is a natural product, which is very interesting. Well, it's interesting for many reasons, and I'll tell you one reason why is that it's only produced in this part of the world, meaning that the Eastern North American region, where I'm going to start from Canada, you know, Quebec and New Brunswick and Ontario, and come all the way down this little belt, of course, the New England states and New York, Vermont leading production in the United States, with Quebec leading the world's production by far, but certain others, Midwestern states like Michigan and Wisconsin and Ohio, it goes all the way down here, where this is where the plants are only found. So maple syrup production, again, happens primarily in Quebec. Canada is producing most of the world's supply, of which Quebec is contributing the most of that. And in the United States, Vermont is leading the United States production, but by far, you know, Quebec leads the world's maple syrup production. And why is that so? Well, for one reason. One, the plants, the sugar maple plant and the red maple, which is also used to collect sap, are only found in this part of the world. They are endemic to this Eastern North American region. Two is that we have a very unique climate. So those of you who have seen maple trees being tapped, you would know that this process happens in late winter to early spring, when you have freeze-thaw cycles of cold nights and warm days. And there's a very narrow window of opportunity, which, because of climate change, changes every year. So it's very variable. as to when they're going to tap trees and when sap is going to flow. But the combination of having the plants with the temperature, is what makes this region this only niche North American agricultural crop. And I would like to say to people, this is the first agricultural crop for the year on the East Coast. If you really think about it, it happens in the spring. And it's of tremendous economic and significant cultural impact to this region of the world. So it is the largest consumed and commercially produced tree tap product in our food chain. I like to say to my students, we eat a large and wide variety and diversity of fruit and vegetables of different colors. But really, when you think of which tree sap is the most consumed in the human diet and in our food chain, it's the sap of maple trees, which is then boiled to become a syrup, maple syrup. The genus of species are called Acer, and Acer saccharum sugar is the sugar maple. Again, I didn't mention this, but the red maple, which is Rhode Island's state tree, by the way. The sugar maple is a state tree of New York, or red maple or a native red maple here in Rhode Island is also used to tap to get sap. So if you've never seen the processing, it's really amazing. Where maple sap, and I thought that sap meant sticky. It's not. It's about 99% water, very watery, and it's collected again, in late winter to early spring, and then processed. Water is removed. It's very energy intensive, but the industry has done fantastic work in terms of reverse osmosis, removing water, and then you have to then ultimately boil. It happens in these evaporators, and in that boiling process, that cooking process of caramelizing the sugar present in sap. As you can imagine, sap is moving nutrients from the soil from the roots to the plant, because it's going to start to form new buds and leaves. It's getting into early spring, and the plant, as you can imagine, is moving vitamins and minerals and amino acids and organic acids in sap, which is, I like to say, the lifeblood of the tree. And then obviously, if you're boiling it down, you're creating that unique flavor and odor that pure maple syrup is known for, as well as really concentrating, all of these natural constituents that you have in sap, which ultimately persists in syrup. So there you go. About 40 liters of sap is required to produce 1 liter of maple syrup, which is why it's such an expensive product. So pound per pound, it's more expensive than crude oil or olive oil, again, because it's such a niche product that's really produced during this short time in this region of the world. But maple sugaring is not. This is not one of the crops that was brought to North America by the settlers. By the people who came from Europe. This was actually here, and it's, again, I'd like to say, a true North American crop, because it was here by the indigenous people, the first people, and there's good evidence that the First Nations, the indigenous people, would actually collect sap, and they would put it into birch baskets and heat rocks and actually drop it in there to kind of evaporate the water off, allow it to freeze a little bit, and maybe get to something that was a little bit not as viscous as we know maple syrup is now, because of they weren't cooking it, but something that was a little bit sweeter. So certainly it continued with the settlers here. An industry that has really changed, from buckets, where you have horse-drawn carts and mom and pop having little buckets to the trees with taps, and then it's being boiled. But hey, I kid you not, this is no moms and pops shop anymore. That happens for sure for hobbyists, but boy, it's a real high-tech modern industry. If you've ever had the privilege of walking into a sugar bush operation that happens here in the New England area, in New York, or even up in Quebec, you can see hundreds of acres of maple trees being tapped with hundreds of miles of these plastic tubing, which is used to collect sap, which is then boiled to get the syrup. So very, very interesting industry. Just showing you more of the processing to get the sugar. But again, significant economic impact. The local farmers here depend on this product. This is important because I believe in sustainability and growing local, producing local. Many people do the same. We want to keep maple trees surviving and erect and good forestry management. We don't want to chop trees down and put up more shopping malls. So it's very important that scientists like myself understand this industry and try to work with the people because of its economic impact, again, its cultural impact to this region of the world. So there you go. That's a long answer for the short question of why I started working on maple when I moved to the East Coast. But our objectives, again, we've been doing this for about 10, 11 years. We're as a chemist, what's in maple syrup and sap and also in the maple tree, and are they good for us? And also, too, is to really increase public awareness of maple syrup. And that's a tricky one here. I like to interject and say, this is a sugar, and I kid you not, we have to understand that no one wants to promote the overconsumption of any sugar, but maybe we want to increase public awareness that there is a difference between someone who is having pancake syrup from pure maple syrup, because one is a natural product, the other is not, or someone who's choosing to use refined sugar versus this natural sweetener. But certainly for people who are sweetener users or want to be looking to use a natural sweetener, for example, honey is another good example, or agave syrup, to educate them, increase awareness, and also maybe as chemists to kind of understand, are people knocking off maple syrup? Is it being counterfeit? Is it really pure maple syrup if they say it is? So that was some of our objectives as we head into this area of research. So this slide is just showing you very quickly, and I'm going to go very quickly over the next number of slides. And the reason is everything that I show you here today, everything has been published. And the papers are available. And you'll see later on, and I'll refer you to URI Maple website, where you can actually go in and get the actual maple peer-reviewed papers from our groups and others to really look and dive into it. And I don't want to bore you here too much with showing you chemistry and chemical structures, but I have to. So again, I'll go very fast. But again, this slide here summarizes, what are the major constituents in this natural product. So for one, it's primarily sucrose. We have established that it's a sweetener. 65% of what's in maple syrup is sucrose, it's sugar. And sucrose is what's refined sugar. However, beyond sucrose, it also contains all these other nutrients, as I was telling you about, which the plant is moving, collecting, and it's in its sap. Amino acids, organic acids, minerals like potassium or calcium and magnesium, which is going to vary depending on the geographical location, as you could imagine. Some phytohormones, which are really interesting compounds. And then this last group here are these polyphenols or these phenolics, which I showed you earlier, are also known to be present in other healthy plant foods like berries and tea and red wine. So you could kind of understand here, and as we started our work, that there was a few papers published that kind of suggested that there may be some polyphenols in maple sap, because as you would expect, whatever is in the sap, whatever is in the tissues of the plant, maybe it's bark or it's xylem or it's phloem or its tissues itself, would get extracted into sap when you pierce the tree itself, and therefore these compounds would be present in syrup as you're boiling or concentrating that 40 liter of sap to get that 1 liter of syrup. So again, just to show you, we've isolated and identified over 60 phytochemicals in maple syrup and maple sugar and maple sap, and the work is continuing. Many of these molecules are known to be present in other healthy plant foods. For example, this is a group shown here called lignans, known to be present like in flaxseed. Every compound shown in red are actually new molecules that we identified, and therefore they're new to nature. They were not identified in any other plant product before. So just to show you again, more of these phenolics. Some of these molecules shown here, which are known to be present like in berries and in tea, This compound here, some of them which are known to be present, like in resveratrol, as I mentioned earlier, which is in red wine. It's interesting that the maple plant is also producing similar type of compound, which is again present in maple syrup. A variety of other smaller phenolics that's present in several berries and other healthy plant foods. This one is known to be present in olive oil. This one is known to be present like in tea. You get the idea as it continues, where again we've published everything. So if you really as a chemist, a science geek, and you wanted to find out more, you can go and dig the papers up and look at them at your own leisure. Some polysaccharides, which are known to be present also. Inulin is an interesting prebiotic polysaccharide, which was identified in maple syrup. So the punchline here is really where I showed you this slide. And what's interesting, and I have to make this point, is that, whereas, you see different foods, like certain foods would have similar type of compounds. For example, berries would have the same common type of compounds, or the cabbage family, the cruciferous, will have the same common type of compounds. Maple, on the other hand, has a little bit of a cocktail, if you will, of little bits, small amounts of different diversity, or a wide variety, not lots, small quantities, but a variety of different chemistries that you find in other healthy plant foods, all within, the sweetener itself. So, we hypothesize that, of course, beyond sucrose alone, these other constituents could impart potential health benefits to maple syrup, which would be superior to having, refined sugar or pancake syrup. And there are a growing body of animal studies and some limited human clinical studies to support that. Just to quickly show that, we identified a process-derived compound, meaning it's not in sap, it's in syrup. As you can imagine, when you're cooking or boiling, that you're creating new chemistries, and these process-derived compounds persist in syrup. This one, we named it after the province of Quebec in Canada, Kibikol, which is an interesting molecule. Why is it interesting? You can see here, you don't have to be a chemist to look at this tamoxifen, which is an anti-cancer drug, and Kibikol, and see the structural similarities between, an anti-cancer drug and Kibikol, where it's present in small quantities. No one is saying that eating maple syrup is going to cure cancer, but certainly the discovery of drug-like molecules from this natural food could then lead to, the synthesis of potential new drugs. I hope you're with me on that statement, or you followed me on that statement. So Kibikol has been synthesized by our group and others, and is currently being investigated, as a potential phytopharmaceutical. Kibikol got a lot of press. The American Chemical Society at that time in 2014 liked it and gave it their molecule of the week. And we like that because our intention, as I said at the very start, our objective was really to increase public awareness. And if we can have, the scientific community taking notice of what's in maple syrup, then hopefully, consumers will start to take interest also. So we did get some attention. The American Society of Pharmacognosy actually focused on our group and talked about the sweet, discovered the taste of success in maple syrup. We got Pop Culture. This is the Providence Journal here showing, maple syrup, as well as our research was published on the trade magazine for the American Chemical Society. Never before have I seen pancakes with maple syrup being poured on it, but certainly it got a lot of attention. You can see here where they talk about Kibikol and other polyphenols present in the food. Today's Dietitian, this is now, 2 years old? I don't have my glasses on. I think it's July, 2018. We got on the cover of Today's Dietitian magazine talking about maple syrup, certainly increasing public attention on this natural sweetener. Quickly though, I'd like to bring your attention back to maple sap, which is maple water. As I mentioned, it's such a watery medium that no wonder, of course, it's used primarily to be boiled to produce maple syrup. But you can imagine where it could be positioned as a functional beverage by the industry. So since it's so watery, it has to be pasteurized or sterilized before it can be safe for human consumption. But our group actually looked at investigating, maple sap and its chemical constituents. And of course, if you can imagine that what's in syrup is what's in sap, then pasteurizing and sterilizing it is even preserving the compounds, because boiling for sure, these compounds are, some of them, not all of them, but many of them are very hardy, if you will, and they do not decompose. They really are resistant. So they're present there in sap. And our research, led to, maple water being positioned by the industry as the new coconut water. Obviously, it's not sugary. There's some small amount of sugar, but it wouldn't have that high calories of maple syrup has, because the sugar content is lower. But again, it's again watery. It's not syrup which has been diluted, but rather the raw sap or the raw water, which has then been sterilized or pasteurized and then can be consumed. So growing attention, if you have not seen this product as yet, then you need to look in your health food stores, maybe natural food stores, but it's really growing in consumer attention. And I hope by listening to this webinar that maybe you can be alert and keep an eye out for it, because I just like to draw your attention here to one local company in the New England area, just north of us. It's called Drink Simple. It's a fantastic product. I have to put in a plug here for my friend Kate Weiler. She has a great website. The website, just to show you here, if you were to just Google Drink Simple, tons of recipes where you can actually, of course, have the product and you can drink. It's fantastic. She's a triathlete and one of the co-founders of the company. But it has hydrating effects, has electrolytes, as you would imagine, has some polyphenols in it, and it can be used as an ingredient in other foods, like to make cold brew coffee, or of course if you're into mocktails or you want to make lemonades or popsicles, or even poach your salmon with maple water. Surely check it out, expand your horizons, and for us, we're trying to promote this product, and beyond maple syrup and maple sugar, we see maple water as also helping to pivot and to help the industry just being to grow further and bigger. Of course, keeping the maple trees upright in the forest here in the northeastern part of North America. So with the little time that I have left, I know we mentioned beauty in the title, and so I like to maybe go off a little bit. What I've said so far pertains to maple foods, if you will. So maple syrup, maple sugar, because you can actually take syrup and crystallize it, and maple sugar is available, as well as maple sap water, which I just told you is available as a functional beverage. But what about other value-added products, and how can we actually expand, or as a scientist, we were interested in looking at developing potential cosmetics from the maple plants, maple plant species, different species there are in this part of the region, as well as maybe exploiting what's called nutraceuticals. So maybe you don't know what nutraceuticals are. Well, this is show you an example. Nutraceuticals are a popular term used to refer to botanical dietary supplements. Shown here, people would choose to maybe drink their tea as a beverage, or their cranberry juice as a beverage, or their pomegranate juice as a beverage. But certainly there's a growing industry where extracts are available as powders, as shown here, cranberry powder, or a green tea extract, which is then put in a capsule, where the bioactive constituents are present in that capsule without, maybe the sugar or the taste. People may not like the taste of the food itself, but maybe exploiting and developing nutraceuticals, from these natural foods. So with that analogy in mind, we have the same idea of looking at expanding, our portfolio and what we're doing with maple research. Why? Well, the herbal industry is huge. It's growing. It's topping 9 billion last year and still continuing to grow. So we actually published a paper some years ago, but we looked at taking. So if you've been a connoisseur of maple syrup, you'll know that there are different grades of maple syrup where you have a lighter grade based on color, and then a darker amber to a darker grade of maple syrup, which the taste differs, and actually the darker the grade, the more the polyphenol content, just so that you know. But there comes a time when there is a very, very dark grade of maple syrup where now the product is so dark that it's off flavored. It has a body off flavor because the plant is now making buds, and so the taste is not good. And the color is so dark that it's not used for putting as a topping. Many people like to use maple syrup as a topping on pancakes and waffles, and also maybe to sweeten beverages. But this byproduct, if you will, from the industry has had no use, and therefore we looked at taking it and developing from it by removing or reducing the sugar content, producing this extract, which we could then enrich in the bioactives, such as the vitamins and the minerals and the polyphenols. It looks like this very interesting, dark, free-flowing powder, but using this, what we called MSX, maple syrup extract, and potentially investigating this as a novel nutraceutical, which could then be taken maybe in a capsule or used as a garnish on salads. So it's something we're thinking of. We've done some animal studies on it. It's non-toxic, it's well tolerated, and we're certainly advancing this in the near future to develop a potential nutraceutical. If you can look behind me, in my office, you could probably see a lot of bottles are on the shelf. There are tons of botanical dietary supplements. As I said, there is no maple syrup extract as yet that's out on the market, but something we're thinking of. What about the parts of the maple tree? If you've ever been to this part of the world in the fall, you will know that there were beautiful foliage this time of the year. Maybe we're past peak season. Peak color already is due in part to several maple species that we have. But I live in Charlestown, which is just south here of Kingstown. And in my yard, I have a lot of oak leaves right now, that I have to go and chop them up, as well as maple leaves. And so our thoughts were, well, can we use the fall leaves that's sitting on the ground and rotting, and you have to dispose of it, to kind of maybe use it to extract it and develop it into a value-added product, which could then, be used for cosmetic purposes or for nutraceutical purposes. And indeed, we did that. We did a lot of work where we isolated the chemistry and identified several new molecules from red maple leaves and stems and bark. And what we did is that we then, through the University of Rhode Island, I'm showing you here, this red arrow, this red box, this red oval shape, the Rhode Island Board of Education. This is now an approved patent where we actually try to protect through a patent, protect the cosmetic effects of these red maple compounds, which we did with the university, and we're inventors on that patent, and that intellectual property that's been licensed to a United States-based company that's located in Indiana, in Noblesville, Indiana, Verdure Sciences. That's then taking that extract, it's called maple leafa, and developing into a product which could then be maybe added into cosmetic products for skincare and beauty. And that's very exciting and interesting to see how that turns out. So here again, showing you more of the same. Those are your green leaves. You can imagine collecting green leaves by pruning the trees. We're not advocating to chop any trees down or really strip bark off trees, but you get twigs and stuff like that. Of course, it's the fall leaves that's collected. This is what the extract looks like, free-flowing, off-white. And then we know all the chemistry of it, and I've done tons of research on this natural product, which again, as I said, is being advanced for cosmetic applications. So just to show you here quickly its effects, we've done a lot of studies to show what it does in cells, as well as in human skin cells, as well as understanding, if it can be what we coin like let's say it's a plant-based Botox to kind of help with wrinkling and tightening up of skin. So interesting what it does here. I'll be happy to talk to you more about that, but in the interest of time, just to leave you there with that slide, and to go off and wrap up with my summary slide. So here is my summary slide, and I have just a couple of minutes to go. But again, the point being is that as a professor, as a faculty, as a teacher, we teach not only in the classroom, but also we have graduate students and postdoctoral fellows, young scientists who are involved in pharmaceutical research, is to really look at the natural product. In our case, this was something that was here. I think this is an exotic plant. I'm from the Caribbean. People think exotic plants are from the Amazon and India and China and where else. It's exotic to me. Right here in our backyards, that's been used by the native people for centuries. I failed to mention that the native people were using the bark of the maple trees to make this liver tonic. So there's good ethnomedicinal background and literature to support its being used. And so we looked at that holistic view of that plant in terms of maybe, of course, it's easy to see that the maple water would be a functional beverage, which is happening, as I mentioned, or maple syrup, which is a food, it's a sweetener, being developed into this nutraceutical, which is sugar reduced or sugar free. So there are clearly food applications as well as nutraceutical and cosmetic nutraceutical applications and beverage applications. The pharmaceutical applications, as I mentioned, where compounds like maybe kipikol can be developed and explored as drugs, but certainly looking at the fall foliage and collecting parts of the plant and really extracting it and understanding how we can develop extracts for nutraceuticals and for cosmetics. So really, taking this really, big view of this plant and its different species and really exploring it, which I think it's important again to this region of the world that I'm now living in, and also it resonates with the people, and it's just been we're having so much fun doing this. So I want to spend just one quick more minute just to quickly tell you what we've been doing with our Maple website. We were funded a year or two ago by the United States Department of Agriculture, the USDA. They have a special program through their agricultural marketing AMS, ACER program it's called, where they funded our grant of one of many to really communicate and market maple products. We developed a website. I'd encourage you to just check it out. If you were to Google, type in www.uri.edu maple, it'll pop up. You can see here where we partnered, myself, a pharmacy professor, with a Department of Communications professor, Yin Zhao Yi, shown here, as well as a marketing business professor, Christy Ashley. We all came together, we competed, we got the grant. It's there on the website. We created a web portal. We're using social media to really communicate, Facebook, as well as Twitter and Instagram and YouTube, to communicate and translate all of the health benefits research that we're doing. Partnering with the industry stakeholders and really hopefully raising awareness, having student involvement, creating this Maple Promotion League where the students are involved because we teach a class, a marketing class, Christy Ashley does, and hopefully increasing awareness like this webinar I'm doing right now to promote maple product sale, which ultimately would benefit the region. That's been pretty exciting. We also work with Johnson & Wales, as you know, has a great culinary school, the Food Innovation Nexus culinary program, and partnering with them to see how we could use maple as a hero ingredient in versatile and other dishes and recipes. So it's been fun. It's been a fun ride, guys. I just listed some names here. It's a lot of people I'm missing, but certainly a lot of tons of undergraduate and graduate students, as well as young junior scientists and postdocs and faculty members from here and from different places, funding from the Quebec maple syrup producers, also from the United States Department of Agriculture, as I mentioned, the AMS, as well as NIFA, their National Institute of Food and Agriculture. So I think I am at the 5 minutes mark. I maybe we'll pass it back to Vanessa and hopefully spend some time to answer some of your questions. Thank you for your time.
Wonderful. The one clap.
Thank you,
Everyone's
Vanessa.
clapping. You're getting a lot of wonderful feedback. Excellent.
Okay, I hope so.
So I'll start with the questions. Is there you went a little bit into the the beauty industry and the uses there, but is there a topical use like Meta honey from Australia?
Yes, that's a great question. As many of you know, honey has been used for centuries for wound healing because it also, like maple syrup, contains polyphenols too, which bees from the pollen from the trees, the tree pollen has polyphenols. We have actually been working more with the extract from the leaves for the cosmetic applications, as well as maybe taking maple sap and adding the extract to that to develop it into a cosmetic. We have not explored syrup use for that, but certainly that's a great suggestion. We haven't excluded it, but it's so expensive, and it's so coveted and people want to consume it. Certainly we would really, look into that for sure. It's just on the back burner for the things we're trying to accomplish. So yes, great suggestion. I believe there would be health benefits because it's sugary, just like honey, as well as having polyphenols. But we haven't investigated that as yet, but certainly it's one of our to-do things to get done.
Awesome. And I love like the agroecology connection and the fact that this is local agriculture that we'd be supporting with these goods, and that there's so many different uses for maple products from all parts of the tree. So that side of me gets really excited hearing about this. A lot of questions about, tapping maple and questions related to that. So does tapping the maple tree slow the spring growth to the tree?
It does not. I'm a chemist again, but I've been to many talks so that there's a lot of good programs up in Vermont Proctor Maple Center, where there's been a lot of science that they know exactly what the age of the tree, what the circumference of it has to be, how many taps they're putting in, how deep the taps are, when they're resting the tree, so they wouldn't tap it, for 10 years in a row, but resting and not resting. So it's all very worked out. It does not hurt the trees. It's actually, they take enough to not kill the trees. So it's been well worked out science. The production of maple syrup and that part of the processing has been tons of research. Where we came in, where there has been less research, was really in understanding the chemical composition and the health benefits. But for sure, guys, yeah, you can check it out. Tons of research in maple sap production and forestry management. Tons of work has been done.
One more question from the industry side. Are you seeing more like people on small properties or cooperative efforts in terms of the industry?
Yes, small properties, as I mentioned, there's many moms and pops and hobbyists, if you will, where because it's such, again, I mentioned such a niche crop that is so cultural that people, they stay with the family-owned farms and they stay and they saw what grandma or grandpa used to do. So yes, there's a tremendous amount of local small folks who would just do it for their own consumption. But at the same time, it's really a booming and large industry where it happens at an industrial scale. I don't know if that answered your question, but yes. If you have maple trees in your yard and you're living in this part of the world, you should go out and tap it. It's fun. It's actually, we have our little kids here in the elementary school explore tapping. It's really fun. So check it out.
So the plant people on the call want to know, is there a difference in the compounds, or have you looked at, the difference between red maple versus sugar maple?
Yes, great question. I didn't mention this. I didn't have the time to get into this. What we found, there's actually a few maple species which are used primarily to tap. Sugar maple is used primarily because its sap has a higher sucrose content, sugar maple. The red maple, its sap has a lower sucrose content, so you need more sap to get to that same bricks, that sugar content. However, sap from sugar and red are very similar in their constituents. What's different, though, is the constituents of the leaves the species. And we have expanded our work. I didn't show this. We've studied actually several species, the silver maple, the black maple, the sycamore maple, red maple, sugar maple for sure. And we see similarities and differences, not in the sap. The sap is pretty much the same, but in what's in the leaves, it's very, very different, believe it or not. So very interesting how the plant will do the same thing for its sap, but then when it gets to its leaves or its bark, the chemistry is quite different.
That is fascinating. Okay, this is a good question because I know you have the answer to it. Do different geographic areas produce maple syrup that have variations in the components, or are there any particular like states or Canadian areas that produce higher concentrations of those beneficial chemicals you told us about?
Yes, the geographical location, as you imagine, this is one of the problems, I think, not problems, but fundamental variability in natural products, where plants from different region, geographical location, are going to have differences, inherent differences in their sap. And it's not really in the polyphenols we find as much, but really like in the minerals that they contain. So based on their soil, the vitamins, and sometimes the potassium minerals like potassium, magnesium would differ content and so on. So yes, the answer is yes, there are differences in some of those constituents. But remember again, to get back to the macro level of once you get to that certain percentage of sucrose, and you're getting that boiling to get that similar taste within the food itself, and the darker the grade it is going to have more polyphenols than the lighter grades.
Wonderful. A couple more questions. Okay, so two came up on this fun topic, but can you talk a little bit about climate change and how that's affecting the maple syrup industry?
Yes, as you would expect, a couple of things are happening, and I alluded to this, where depending on how warm it is year after year, that the narrow window of opportunity for the farmers or the producers to collect sap changes. So indeed, there have been anecdotal reports of some year sap will flow a lot if it's warmer. Some year it flows less, and there is, of course, because of the climate changes. So it's some years it may be 3 weeks, some years it'll be a little over that, some years it's less than 3 weeks, as well as some evidence that the trees are actually declining in terms of growth. There are less sugar maples, the southern regions you go, and more as you get more northern, to Vermont and up to Quebec, you have more sugar maples, more red maples in Rhode Island, for example. But yes, so there is evidence, and I'm certainly not an expert at this, but there is, again, good groups looking at the influence of climate change on the maple industry. I've heard one person said maybe 100 years from now, there will be no maple syrup. So, hey, I don't want to scare tactic you, but enjoy the food right now. We don't know what the future holds.
Wonderful. Well, it was so great to learn more about. I think there's so much more to learn here, and I look forward to hearing more about this fascinating topic. Again, if you want to advance the slide one more moment, Dr. Saram, we invite everyone to check out the University of Rhode Island Cooperative Extension YouTube page to find the posted video recording of this talk, usually posted within a week with closed captioning. And we also invite you to come to our webinar next Tuesday. So held on Tuesday evenings through the end of this year. And again, thank you so much, Dr. Saram. And we invite everyone on this call to also check out that awesome Maple website. So it's uri.edu/maple. So thank you so much and have a good evening.
Thank you, Vanessa. Thank you, everyone, for listening in. Bye all. Be safe.
Some really cool stories in the comments.
They are.
Yeah, so